Next, we are going to talk about some of the functional interfaces which were introduced in Java 8. And in order to do that, I'm going to create a new Java class, and we'll say stream API lambda. Okay. Now, what I'm then going to do is I'm going to create a class so that I can use that class here. So I'll create a customer class. And just to save some time here, what I'm going to do is I'm going to put some pre-baked code here, and I'll explain to you what that code is. It's a pretty simple code. We have a class called customer. It has name, country, age, the tier of the customer, the balance, and I have a constructor. This constructor has everything um, getting pulling from the constructor argument, but the only thing is the tier, right? The customer tier is by default set to tier 10, which is the lowest tier for our case. And then we will use the streams and then the lambda expressions to assign this customer tier. We have set tier method, which is just a setter, and then we have a toString method overridden, which is simply printing us all the variables in just a string. So I'm going to use this class customer in my API lambda class. So let me start with this. I have a public static void main, and the first functional interface which we are going to talk about is supplier. So if I show you the way supplier looks like is supplier equal to new supplier. So this is to show you what is the method which is available in the functional interface. So supply is a functional interface which was introduced in Java 8, and then it has one method. It's called get, and then this is basically used to fetch some information either from database or from messaging queues or something. So consider this supplier as the source of data on which we would do further processing. So I am going to change few things in this supplier. So in this supplier, I'm going to say this is going to give me a list of customers. Okay, just the imports, and then I have a new supplier who is giving me the list of customers, and then I get a list of customer out of it. Okay, and then I have some code just to save some time there. So this is a supplier lambda function interface. We are using it to fetch a list of pre-baked list here of strings, list of customers. We can now, once you have written that, right, you know that this function interface can be further reduced using the lambda expression. So let's do that. Let me show you the way you need to write that is you can have this supplier, and you don't need to write a new supplier and all that kind of stuff. The lambda expression will automatically take care of that. So you can simply write supplier 1, and now you have supplier 1 which you can use. So okay, so instead of supplier 1 I would simply write it nameless, and this one I would say nameless 2. So now I have this nameless 2 dot get dot stream dot for each. I just want to do a s out. Just to simplify it, I can comment this code so that we know that only this lambda expression is working. So we have this name list2. It is giving us the list of these customers. We are getting it, we are streaming it, and we are just printing it. So now if I run this, you would see that we are getting the full list. So the supplier functional interface is working as we expect. The next thing, or the next functional interface I want to show you is the filter. So for filter, there is a functional interface introduced called predicate, and this predicate is for customers. So I am going to filter my customers based on, let's say, customer predicate whose balance is greater than 2000. Okay, you can create any conditions like that, and then I can simply say new predicate, and then if, okay, so return customer dot balance. Okay, if it is greater than 2000, I want to return a true, else I want to return a false. So this is a predicate which I have written. Now what I'm going to do is I'm going to convert this into a lambda expression just to simplify things. I would just put another name here, and then if you want to simply write up lambda expression, this is pretty easy. You don't need any method body or something. You can simply write it in one line, and then you can use that into the stream API. So I am going to use the same name list2 because that is a supplier and is already giving me a list of customers. I'm going to do a get dot stream, and then I'm going to do a filter. If I put this predicate inside this filter, what it will do is it will only give me the customers for which the balance is greater than 2000. So I'm going to do an s out for that just by putting this additional condition. Yes, so I'll do it s out, and I will use predicate here, so we'll know that this output is coming from the predicate side. Okay, similarly, let me do the same thing for supplier. Now if I run it, you would see supplier is okay. Supplier is giving me everything, but predicate, due to this predicate, we are only getting these three balances, these three customers for which the balance is more than 2000. So this is the example of the functional interface predicate. The default method for this is test. So similar to what we have the default method as get for the supplier, we have the method, only one method which is available is called test. Let's move on to the third functional interface which has been introduced in Java 8, is called function. So let me do this. It's a map type of functional interface. When I say map, means it can return you, it can accept different type of object and it can return different type of object. Not necessarily it should always do that, but it can have an input type and output type as a different data types. Okay, so function, and I would say we are going to get a customer, and then we are going to return the age of the customer. Okay, so I am going to integer, I'm going to say function equal to new function. The simple thing which I'll return from this guy is customer dot age. Okay, so I'm accepting a customer and I am returning the age of the customer, and soon you will understand the reason I did that. So now how can I use this functional interface is basically I can use it to convert the array or the list of customers into their into another list which is only having the ages of them. So if I do this get dot stream dot map, then I can use this function, and then I can do for each, and then do a s out. Oh, sorry, even do instead of do an s out, I will write it this way so that we know it's coming from. Okay, if I run it, here you see the function was taking the customers as an input, but it has converted that into another list, and for which we are iterating through. So it is giving me the ages of these individual customers. One thing which I didn't show you here is how can we write the same thing using the lambda expression. So I'll use this one here, replace with lambda, and just function one here. So this is pretty easy. This is simply converting the function into just one line. It would give us the same result. So if I run it again, okay, so this is superb. The last thing I want to show you, the last functional interface rather, is the consumer. So consumer is basically a ternary operator. It will cause the whole stream to be calculated, and then will perform the operations. So if I write it consumer, and I'm taking a customer as an input, okay, and I'll write consumer equal to new consumer. And here I am simply doing an output of consumer customer. I have created this consumer just to print out something. Okay, so name list2 dot get dot stream dot for each, and this just this consumer. What this will do is it will simply print anything which is coming from the supplier functional interface, and then we are just using this consumer. Now you can also use this consumer to putting these messages into Kafka or putting these into somewhere else. Okay, that's it for this section. Thanks for watching, and see you in the next section.